Soft Tech Insights, simplifying technology for every level. Have you ever wondered how your brain learns something new? Today we're going to explore how artificial neural networks work, and it's simpler than you think. So, what exactly is a neural network? Imagine your brain. It has billions of tiny cells called neurons, all connected together. When you see a cat, millions of these neurons fire signals to each other until your brain recognizes. That's a cat. A neural network in a computer is inspired by exactly this. It's a system of connected mathematical units, artificial neurons, that work together to recognize patterns, make decisions, and learn from experience. And just like your brain got better at recognizing cats the more cats you saw, a neural network gets better the more data it processes. Let's zoom in on a single artificial neuron. It receives multiple inputs. Think of them as signals coming in. Each input has a weight, a number that says how important that input is. A positive weight means the signal matters a lot. A negative weight means it actually pushes back. The neuron adds up all the weighted inputs, then passes the result through an activation function, which decides whether the neuron should fire or stay quiet. Think of it like a volume knob and a threshold. Turn it up enough and the signal gets through. Too quiet and nothing happens. Now imagine stacking thousands of neurons into layers. You have an input layer, where raw data comes in. Hidden layers in the middle, where the actual thinking happens. And an output layer, where the answer comes out. When data flows from left to right through all these layers, that's called the forward pass. Early layers learn simple things, like detecting edges in an image. Middle layers combine those into shapes. And the final layers assemble those shapes into recognizable objects, like a cat's face. This is how a neural network builds understanding, one layer at a time. After the forward pass, the network makes a prediction. But how does it know if that prediction was good or bad? That's where the loss function comes in. It measures the gap between what the network predicted and what the actual correct answer was. Think of it like a score on a test, but instead of higher is better, lower is better. Zero loss means perfect prediction. High loss means the network is way off. The loss function gives us a single number that tells us exactly how wrong the network is, so we can work on fixing it. Now comes the magic, how the network actually learns. Once we know the loss, we send that error signal backwards through the network. This is called backpropagation, or backprop for short. Imagine throwing a dart and missing the bullseye. You don't just shrug and try again randomly. You think, okay, I threw too hard and aimed slightly left. So you adjust. Backprop does the same thing mathematically. It calculates how much each weight in each layer contributed to the mistake, then adjusts every single weight just a little bit in the right direction. This adjustment process is called gradient descent, like rolling a ball down a hill to find the lowest point, which represents the smallest possible loss. So let's put it all together. Training a neural network is one big repeating loop. Step 1. Pass data through the network, the forward pass. Step 2. Measure how wrong the prediction was. Calculate the loss. Step 3. Send the error backwards. Backpropagation. Step 4. Update all the weights. Gradient descent. Then repeat. Thousands of times. With millions of examples. After each round, called an epoch, the network gets a little smarter. The weights get a little better tuned. And slowly, almost magically, the network learns. A network that started by guessing cat or dog randomly at 50% accuracy might reach 97% after training. That same process powers the AI that recognizes your face to unlock your phone, translates languages in real time, detects diseases in medical scans, and drives cars safely through traffic. And that's how neural networks actually learn, from zero to expert, one tiny adjustment at a time. If you found this helpful, please give this video a thumbs up and subscribe for more clear explanations of AI, machine learning, and software engineering. Drop a comment below. What topic should we break down next? See you in the next one.